Welcome students for the fourth lecture on standard deviation, part 4 of standard deviation. As it was told, this part is dedicated for combined standard deviation. Today we will be learning combined standard deviation. Till date we have learned how to calculate standard deviation for one or single set of data. Marks obtained by students, daily wages earned by workers from a factory, likewise. If we have multiple such data sets and we have to find standard deviation for all these data sets together, then how to calculate? For example, let's say I am having marks obtained by data regarding marks obtained by students from A division, B division, both. Then I can calculate the standard deviation for separate divisions separately, that we have learned. But if I have to combine both the divisions, their students and their marks, and I need to calculate how much is the deviation in this combined series if I have to combine both the divisions. In that case, just combining all values and going for normal formula of standard deviation will not work, because number of observations in both the series will be different. The average calculated will be based upon different value sets. So in that case, proper approach will be to go for combined standard deviation formula. So if you can pay attention towards this formula, combined standard deviation, sigma stands for standard deviation, C stands for combined. Formula is available, square root n1 into bracket sigma 1 square plus d1 square plus n2 into sigma 2 square plus d2 square divided by n1 plus n2. Now you will wonder, so what is this sigma 1 square? Sigma is standard deviation, sigma square is variance that we have learned. So what is 1 and 2 then? As I have told you, we are going to have multiple data sets, not only one, at least two or more. In that case, how to identify or differentiate between two data sets, their values? That's why we are using 1, 2 or any other numerical values to differentiate these. So standard deviation variance will be for both data sets, number of observations will be represented for both. So how to differentiate? So n1 represents number of values in first data set, n2 represents that in second data set. Sigma 1 square represents variance of first data set, sigma 2 represents variance of second data set. Now you will wonder, what is d1 square, d2 square? D stands for deviation. Here deviation will be taken from the combined mean. So first of all, our job will be to find out combined mean, that we have learned already. So we will calculate it, and then we will learn how to calculate the deviation, both d1 and d2, and then we'll go ahead with the calculation of combined standard deviation. So let us consider first sum. Let's say there are two divisions and there are number of students in both divisions. Let's say first division is having 50 students, whereas second division is having 100 students in it. Average marks scored by first division students in one exam are 54.1. In the same examination, the other division students are having 50.3 as average marks. Now, we are also told that the amount of deviation in marks obtained by first division students are 8, and that for second division students are 7. That much is the amount of deviation obtained in the marks obtained by students of respective division. Our job is to find out for all these 50 plus 150 students together, how much will be the amount of deviation in their marks. As you know, number of observations, that is number of students, are not say equal, so we cannot go by same formula. So to go for the combined standard deviation formula, our first job is to find out combined mean, so that we can find out the deviation d1 and d2 values. Okay, so let us consider the first sum. As we started discussing that there are 50 observations in first data set, 100 in second. Average values of both data sets are given, standard deviation for both data sets are given, right? So we have learned combined mean formula as x bar c stands for combined, n1 x1 bar plus n2 x2 bar upon n1 plus n2. We know that this formula can be extended up to n number of data sets. Fine. So as we have two data sets, we are writing this formula up to two data sets. Let us substitute values. N1 is 50, N2 x1 bar is 54.1. So multiply these two plus N2 into x2 bar, that is 100 into 50.3, divided by N1 plus N2, that is 50 plus 100. So using BODMAS, we can solve these two brackets first, then we can add their values, divide by 150, we get this answer, 51.57. Remember, use BODMAS and do calculate this value properly. Okay, now once we have this, as we were discussing, D stands for deviation. Deviation for first data set, deviation for second data set, both are required. So let us differentiate between these two. D1 for first data set, D2 for second data set. What is the formula? D1 is x1 bar minus x bar c, that is first average of first data set minus combined average. Whatever is the difference will be your D1. So average of first data set is 54.1, which is given data, minus what we have calculated just now, combined average 51.57. Subtraction will be 2.53. It is approximated up to 2 decimal places. If you refer the formula for standard deviation, you will understand we need square of it. So let us square it. So D1 square will be 2.53 square, that is 6.40 approximately. Now on the same ground, let us calculate D2. D2 formula will be x2 bar minus x bar c, average of second data minus combined average. So average of second data is 50.3, which is given data, minus 51.57, that is combined average, which we have calculated. Difference is, okay, you may get a negative difference or a positive difference or a zero, may happen. So don't worry if you are getting zero or negative or positive values. Here difference is minus 1.27. So, but we need square, so squaring minus 1.27 gives us a positive value, that is 1.61 approximately. So we have got D1 square, D2 square, we have got N1, N2, we have got sigma 1, sigma 2, but we require square, so we can easily square these two values. Square of sigma 1 is square of 8, that is 64. Square of 7, that is sigma 2, is 49. We can easily do it. So let us substitute these values in the formula. Obviously, our first job is to write the formula to avoid confusion or error. So sigma c, that is combined standard deviation, is equal to square root n1 into sigma 1 square plus d1 square plus n2 into sigma 2 square plus d2 square upon n1 plus n2. Substitute these values that we have calculated just now. We know that n1 is 50, given data, into bracket 64, that is sigma 1 square. Sigma 1 is 8, so its square becomes 64, plus d1 square, which we have just calculated, 6.40, plus n2 is 100, into bracket sigma 2 square is 49, plus d2 square is 1.61, divided by n1 plus n2, 50 plus 100. So again, solve this bracket first, multiply by 50, then solve this bracket, multiply by 100, add both the values, divide by 150. Don't forget to take square root at the end to get this value of combined standard deviation, that is 7.69. So both divisions, if we combine, consider together, then amount of deviation in their marks obtained will be 7.69. Okay. Now, somebody may ask, sir, what about if we have 3 divisions? Obvious question. We can have 3 divisions. We can solve by using the same formula. Only the cases we have to extend this formula for 3 data sets. So let us have one sum over 3 data sets. So let us consider one sum where we have 3 data sets. Okay. So assume that there are 3 divisions. A, B and C. First division, second division and third division. And now for these 3 divisions we are supposed to calculate deviation in marks obtained by students of these 3 divisions. So how to calculate it? Let us have data first. Let us say there are 100 students in first division, there are 90 students in second division, and let us say N3, that is third division, there are 200 students in this division. Fine. So we know how many students are there in this division, these 3 divisions. Now let us write down average marks obtained by students of these 3 divisions. First division students are scoring average 35 marks. Second division students are scoring 60 marks on an average basis. And third division X3 bar average is 50. There are average marks are 50 for third division students. How much is the deviation in their marks? Standard deviation for first division 7 marks, second division sigma 2 4 marks, and for third division standard deviation is 8. Now our job is to find out combined standard deviation. Now instead of 2 we have 3 data sets. Now our job is to first find out combined mean. Now I have to extend this formula. So it will be numerator will be n1 x1 bar plus n2 x2 bar plus n3 x3 bar upon n1 plus n2 plus n3. Right? Now let us calculate. Now my values will be, how much is n1? 100 into x1 bar, that is 35, plus n2 is 90 into x2 bar is 60, plus n3 is 200 into x3 bar is 50, divided by n1, that is 100, plus n2, that is 90, plus n3, that is 200. Fine. So we have substituted all values. If you again calculate values for these three brackets separately, add their values and divide by addition of these three, that is 390, you get combined mean x bar c as 48.46. If you calculate, then approximated answer up to 2 decimal places will be 48.46. This much. Okay. Now next step will be calculate d1, d2, d3 and their squares. So d1, what is the formula? x1 bar minus x bar c. Average of first data minus combined average. How much is the average of first data? 35 minus combined average 48.46. So how much is the difference? Difference is negative, that is minus 13.46. Whatever is the difference, negative, positive, it's not a problem for us. We need d1 square of this. So square of minus 13.46. How much is the square? 181.17. This is the value which is required for us. Now d2, how to calculate d2? d2 is nothing but x2 bar minus x bar c, that is average of second data minus combined average. Average of second data is 60 minus the combined average 48.46. So difference comes out to be 11.54, but we require the square of it. So d2 square is equal to square of 11.54. And how much is that? It comes out to be 133.17. Fine. Now our job is to find out d3. d3 is also required because we have 3 data sets. d3 formula is x bar 3 minus x bar c. Average of third data set minus combined average. How much is that? 50 is the average of third data set minus 48.46. So the difference comes out to be 1.54, but we need square of it. So d3 square is equal to square of 1.54, that is 2.37. So we have got all three values, d1, d2, d3 and their squares. Now let us substitute these values in the formula of combined standard deviation. Now, like combined average, we have to write down the formula for combined standard deviation sigma c. Now as we have 3 data sets, we have to extend this formula up to 3 data sets, that is n1 into sigma 1 square plus d1 square plus n2 into sigma 2 square plus d2 square plus n3 in plus d3, sorry, it should be not n3, n3 into sigma 3 square plus d3 square divided by, entire term divided by n1 plus n2 plus n3. So we were used to up to 2 data sets. Now we can expand it for 3 data sets. Now let us substitute values in it. One by one, we have all values. How much is N1? N1 is 100. 100 into bracket. How much is D1 square? Square of 7, 49. Plus D1 square. D1 square we have calculated 181.17. Plus N2. How much is N2? 90 into bracket. Sigma 2 square. Sigma 2 is 4 square will be 16. Plus D2 square 133.17. Plus N3 is 200 into bracket. Sigma 3 square. Sigma 3 is 8. Sigma 3 square will be 64. Plus D3 square, that is 2.37. Bracket close. Entire term divided by N1 plus N2 plus N3, that is 100 plus 90 plus 200. 100 plus 90 plus 200. So if you solve first bracket multiplied by 100, solve second bracket multiply by 90, third bracket multiply by 200, you get the answer for numerator. Divided by 390 and then take square root. Don't forget to take square root. Then we get answer of combined standard deviation as 11.29. So first sum we had for 2 data sets, second sum we had for 3 data sets. It is easy if we follow the procedure, that is defining all these values properly. This step is very important. If you do not define data values properly, then the substitution will go wrong. Okay, the next step will be to find out combined standard deviation, then deviation in their square values, then writing the correct formula for standard deviation, combined standard deviation, substituting correct values in correct way, and calculations. Again, this final value is rounded up to 2 decimal places. Now we have seen 2 sums for the same concept, that is combined standard deviation, where all these values were given and our job was to find out combined standard deviation. And first sum was for 2 data sets, second was for 3 data sets. Now it may happen that you may get 4 data sets, 5 data sets, 6 data sets. Procedure remains the same, only you have to expand the formula as per the number of data sets available. Okay. Now it may happen that combined standard deviation value will be given to you, but one of these values might be missing. So you have to calculate that. We know in basic mathematics, the rule of basic mathematics says in one equation, if one quantity is unknown, then we can calculate it. So if 1 or 2 or 3 values are missing, accordingly we can calculate it using the same formula. So if combined standard deviation value is given, then might be the case that some other value here might be missing or unknown. Then you have to find that value. So using the same formula of combined mean and combined standard deviation, you can find whichever value is unknown or missing. May not be every time combined standard deviation, maybe standard deviation of first, second, third or any data set, or average value, or number of observations. So using these 2 formulae, we can find it out. So I'm going to give you couple of sums, more than couple of sums to solve. Please do solve using same method and see whether you are able to get the same answer. So I will be giving you answer keys also, just reference answers. Please do solve sums which I will be giving you right now and have more practice over it. Practice, if you have more practice over these solving these sums, it will be better for you. Confusion will get clear if you practice more. So we have seen 2 sums over combined standard deviation, and I'm going to give you a few sums to solve. So first sum for solving, I will be giving you data set directly. Here in this sum, there are only 2 data sets and you have to find out combined standard deviation. This is first data set. Your job is to find out combined standard deviation. Now the second data set. Now let us have second data. Here also you have only two data sets. Okay, this is your second data for solving sum. Now I will be giving you two more sums for practice. These are somewhat different, as I have discussed with you just now, that every time combined standard deviation may not be the question. It may be given to you, value of combined standard deviation, and one of the value may be missing here. So you have to find that. So accordingly, the same formula you have to use, only which value is supposed to be calculated will be different. So let us have this data for third sum. Third sum, n1 is 50, n2 is 50, n is 100. First data set average value is 10. Second data set average value is unknown. First data set standard deviation is 2. Second data set standard deviation is unknown. Combined average is given as 8. And what else is given? Yes, combined standard deviation is 3.24. Now using this, your job is to calculate standard deviation of second data and average of second data. Okay. Now last sum for you to solve. Fourth sum. Fourth sum, let us have data n2. Okay, n1 is equal to 50. Then we have n is equal to 200, n3 is equal to 90. Then we have combined average as 116. Average of first data is equal to 113. Average of third data is 115. Then we have combined standard deviation as 7.746. Then standard deviation of first data set and that of second data set. What is to be calculated here? You will understand n2 is missing. Then what else is missing? Average of second data set is missing, and standard deviation of third data set is missing. So these three are the unknown quantities. Find these values and refer with the answers which I am going to give you just now. So answer key I will be giving here for you to verify. Question number, let's say 1, you were supposed to calculate standard deviation, and here combined standard deviation value is 12.26. Now question number 2, again in question number 2, question was for combined standard deviation only, and value should be 7.56 on approximate basis up to 2 decimal places. Now question number 3, here your job is to find out these two. x2 bar, average of second data set, it should be 6, and standard deviation of second data set should be 3. Now question number 4, third is over, 4. You were having 3 questions, so n2, x2 bar and standard deviation of third data set. These three are the questions, so n2 should have value 60, x2 bar should have value 120, and the standard deviation should be 8. So these are the answer keys for you to refer. Refer these at the end. solve question number 1. This is for combined standard deviation. This is also for combined standard deviation. Solve these 4 sums and check whether you are able to solve these questions properly. So first 2 questions are straightforward. Here these last two questions, 3rd and 4th, are somewhat twisted, where combined standard deviation is given and your job is to find out some other value. Fine. Okay. Thank you for attending this 4th lecture, 4th part on standard deviation. Now in next lecture we will be having few more sums over standard deviation. Topic will be somewhat different, and then we'll be going ahead with coefficient of variation. So subscribe my channel. Don't forget to like my video so that you will be able to get the notification for new videos. Practice more for getting accuracy. Thank you.